Hey everyone, welcome this afternoon to .NET Advanced by Ewout Kramer. You guys are welcome to post your questions in Q&A, but we have been having some troubles with the Q&A refreshing. So if you don't see your question answered, then please let me know by raising your hand and I can unmute you. Ewout has asked for me to unmute you only at the end of his presentation. So he's going to give his presentation first, and then I will be able to unmute you to ask your questions. Ewout, I hope you're ready, and I'm going to unshare my screen so that you can begin.
Yes, I guess that works. Hello, everyone. Welcome to my home. Thanks for joining me for this session on advanced parts of the .NET API. What I'm going to tell you today is about how you can use parts of the API to parse your data without using POCOs and so on. And well, you know me by now, maybe from the openings and making a total fool of myself, but I'm also a software developer, and working with my FHIR colleagues, we maintain the .NET API, the .NET SDK, as we call it now, and on a daily basis. So if you're doing pull requests or issues, it's me or my colleagues dealing with them. So it's an honor for me to be talking to you about this. This is a new presentation. So lots of stuff that I haven't tried before. So this is a first. And I am going to try to show you a lot of code. That being said, well, this talk is about the advanced FHIR.NET SDK. And the first thing actually I want to tell you about is an announcement. And just this week, it's no coincidence, of course, we released the 2.0.0 version of the FHIR.NET SDK. It's been in beta for a while, but we have tried it with some of our biggest clients first, and now it's, we think, ready for release. Very cool new features, I think, is a long-awaited addition or actually change of the FHIR client. This was based on HTTP web request, HTTP web response, which, to be perfectly honest, was net 2.0 stuff. And we had multiple pull requests for changing it to HTTP client, which means it now works with more modern security infrastructures. And it's also easier to configure. And that was yeah, it took us a while, but we're happy that we made that. Also, and that's important for if you're working with multiple versions, which of course sometimes happens. If you're working with multiple versions of the FHIR SDK, so you have to build software that works with R3, R4, R5. We've made sure that more and more code can be shared between the libraries, because if you've done that, you know that you just need to download NuGet packages for each different version. And if you want to make software that works with all three versions, it's really nice now that classes like resource, meta, identifier, some of the more common data types are now in the common parts of the API. So they're shared across, makes it way easier. We were allowed to throw away a lot of our code in, for example, Vonk or Simplifier because of this. So that's pretty cool. Also, when we started this library 7 years ago or so, async wasn't really there yet. So now we've added async support to some parts of the API. If I have time, I'll show you that later. That, of course, meant a breaking change. So we had to wait until we went to 2.0 of the API. We have now support for FHIR normative, which is nice if you're using that, and better support for using the whole infrastructure with non-FHIR stuff like CDA. Yes, that's possible. I'm not going to talk about that today, but it is possible. Maybe on the negative side, we have no more DST2 support. And of course, there are breaking changes. We batched them and put all of them in 2.0. But so far, people who have tried it say that it wasn't really too hard to get going. All right, without that out of the way, actually, you can learn a lot about the internals of the API and the advanced stuff that I want to talk about today just by looking at this little bit of code. this is the code you guys have been using probably a lot. It just parses a patient from a bit of XML and turns it into a POCO, one of the predefined classes. What I want to do now here in this tutorial is see what's behind this. So what actually happens when you do parser.parse. And by doing that, you'll learn a lot about the internals of the API and also about how you can do this without being dependent on a POCO class like patient, as you see here, or any of the precompiled stuff. I think it's best if I just show you that in code. So this slide is just there. It's it has most of the code I'm going to show. This is for those not here, unlucky enough to not see this session. But you know, you are here, so I'll just invite you to my Visual Studio, which is here, and I've created a unit test, and this is going to be the center of our universe for today. So, what is actually the parse instruction doing in the .NET API? Let me grab a little bit of code. I'll go on this one by one. So let's take a look at this bit of code. Let me see if you can see. And I enlarged my font, so you should be able to all read this pretty well. The first thing we need to do here is obviously, well, the first lines of code here is just read a bit of test data, test patient JSON in this case. And what I'm doing here is I'm using a class that you might not have seen before, FHIR JSON node, and I say parse this JSON. And the output of this is not a POCO, but it is actually a iSource node. Now, iSource node represents FHIR data, whether it's an XML or JSON, on the lowest level. And I'll tell you a little bit more about that, but you just now assume this is a tree. So what I'm going to do first here in this bit of code is iSource node has an extension method called visit, which will visit all the nodes in the tree and run this lambda here. And this lambda doesn't really do more than dump whatever we've encountered. So you can see that for every source node we encounter in the tree, I print a location, I print the name of the node, and if there is a value, I print the value of that node. Now, would be best, of course, to run this bit. Let's see if that works. Of course, it did 5 minutes ago, but build started. Build succeeded, that's nice. And I think the test ran as well. Yeah, it passed, good. Well, let's see what the output was. So much as you could expect, you can see that it has now printed line by line, or actually going in a tree traversal, it has printed the contents of the file, in this case a JSON file, but you really don't see that anymore. iSource node abstracts away from that. So you can see we go into ID and everything, every value here is a string. So this is really at a pretty low level. There is no knowledge really about the FHIR spec here. It doesn't really know that it's reading a patient. It just knows it's been reading JSON or XML. So although this looks like completely one-on-one FHIR data, I can show you that there is something to note here. It's not completely there based. For example, oh, get my notepad here back. Thank you. Let's enlarge this a little bit. There is something I wanted to show you, because down here there is a field called patient.deceased, and in fact normally it's deceased X, but then of course on the wire it's deceased Boolean. And since I don't have type information here, all I know is that there is a field called deceased Boolean, but I don't really know that it is actually a FHIR field called deceased of type Boolean. We don't know that yet here. Let me tell you a little bit more about this iSource node before we go on. So,
Ewout?
Yeah.
I have some questions about people that it's quite unreadable actually, your screen. Is there a way to improve it, you think?
Well, so is the code unreadable?
Yeah, the code and also the characters that you're the other text.
Even with the big font?
Yeah, I'm afraid so.
You have the optimize for video on when you shared your screen.
I'm not sharing a screen actually.
Oh.
This is all my webcam, so that might be the problem, which of course I could share, but it just means a little bit more more going back and forth when I want to go between my presentation and this.
Yeah, but perhaps it's a good solution. Yeah.
Let's see.
Yeah.
I can just say share screen and share. Let's share my Visual Studio here. Share.
Yeah.
Now you see the code, right?
Yeah, great. Thank you, Ewout.
Well, that's good, because most important is that you can at least see this. This was the bit of code that I see for those who weren't able to see it. I have been reading the JSON file, read it into this iSource node thing, and then when I ran this, I'll open the output again. You can see that this went through the JSON file, although you can't see that it's XML or JSON anymore. You can just see a tree traversal with the data in the file displayed. Now, let me see, because now, of course, I do want to share. Let me see. Let me get my slides for you as well. I have them here too, luckily. So there we go. We'll just change strategy here and share this presentation. Let's share.
That's readable now.
That's readable now, and that's better. And I hope you can see the slides here too.
Yeah, that's great.
Yeah,
good. Well, we're just in your PowerPoint, so you have to press play or something.
I know that. See?
Okay,
I
great.
to check. Oh, see, now we get presenter view, of course, which I don't want. Use presenter
okay,
view.
yeah.
I'll just, we'll just hold on, I have to improvise a little bit now.
Yeah.
Because of course I want this on, I don't want presenter view, but I want it here on this screen. Well, it doesn't work. Why won't you show this on my screen here? This is my primary monitor. Internal display, of course, it's my laptop's monitor. That should be it. Yep, there we go. All right, so iSource nodes, Visual Studio, iSource node. Why? So as I said already, this presents XML and JSON on the lowest level. And in fact, you could present all kinds of data here. It abstracts away from the actual syntax, XML, JSON, and so on. And if you would implement iSource node for any other format, for example, comma-separated files, it would just blend in with the rest of the infrastructure that I'm going to show you later. So the interesting also, for example, if now with .NET 5 being around the corner, I'm still using Newtonsoft JSON in the SDK. So if you want to switch to the new .NET built-in JSON stuff, you'd implement iSource node on that, and then we'd be using the more performant .NET 5 JSON parser. I'd love a pull request if you guys would do that for me, and so on. So that's iSource node. Now, the thing is, with a source node, you can't really do a lot. A source node has no type information, and all the other things you would like to do on top of it really needs type information. So to do that, we need to add type information. I'm going to show you right now how we do that in code. And we promote actually from a iSource node to an I-type element. And while I'm here, because I don't want to switch lots of times anymore now, I-typed element is like iSource node, but with added type information. So now we have access to the FHIR metadata. We know the types of each element, but still we are not needing POCOs. We have no version dependency necessarily because we can read it from the FHIR specification. And the good thing about I-typed element is it will read any kind of data. It will try to read your data even if it's slightly incorrect. If you've tried parsing POCOs and it fails, you know that there's not much you can do. But if you read into I-typed element, there's way more you can do. So you can access parts of FHIR data that are incorrect. You can access partial parts of the tree, so you don't have to read the stuff completely in the POCO memory. And for example, for our Forge tool that our dear moderator Abel has been maintaining for a while, it's really necessary that you can read incorrect profiles and correct them in code. And of course, it's really easy to read across versions. So I-typed element also actually represents a tree, but now it's a typed tree. So each node has a name, and this time, like I showed deceased Boolean, in this case, because we have time information, the node name would really be deceased and the type would be Boolean. So there is, in this interface, there is the actually name. So this is now value or deceased. Instance type would be Boolean. And as you can see, the value is no longer a string. There's also a property called value. And this value is of type object and will be the parsed value. So if the spec says this is a FHIR Boolean, we'll parse it to a .NET Boolean. If the FHIR spec says it's a date, we'll parse it to a .NET class called date. And so this way, it's way easier to work with the data. Let me switch back to my Visual Studio again. We can up. So this was the code we had. And let me just paste a little bit more code. So I'm going to add type information. How do we do that? That's pretty simple. We have this source node here. But now we're going to say, please turn this source node into a typed element. And the return type of this extension method is actually I-typed element, which is the interface I just showed. That also means that we don't really need this stuff anymore, because we're now going into a beautifully typed world. But you can see there's still an argument that I didn't provide. Let's use IntelliSense to see what it is. You can see it needs an iStructure definition summary provider. And this is a class, any class that implements this promises, or actually provides the metadata coming from the FHIR specification. And there are multiple ways to get it. You could get it from packages. You could get it from the zip file that we give you with the NuGet files. I guess tools like our FHIR server get them from the database. It doesn't matter in this case. We abstracted that away with iStructure definition summary provider. So what I still do need, of course, here is I need an actual provider. And in this case, I am using a POCO structure definition summary provider. If you're wondering why we made the names this long, it was always the intention for these classes to be internal, or actually to be replaced very quickly by something else. But you see how these things goes. This was 3 years ago, and it's still there. So we're now stuck with the names. POCO structure definition summary provider is a metadata provider that doesn't use external XML or JSON files coming from the spec, but this reads the metadata for all the patients and all the resources from the actual POCO classes. I can actually, let me take a second to show you that. If I go to patient.cs, please. Yeah, that's generated code, that's right. If you look in that class, you can see there's all kinds of annotations here, which hint to the actual FHIR metadata. So this FHIR class patient is actually of patient, well, obviously, and it's a resource. And all elements inside carry things like FHIR element to specify the name. So what this typed element, this POCO structure definition summary provider is it will quickly, as quickly as reflection goes, get all that stuff from the classes and provide that to the typed element. Now, of course, once we've done that, we can now we have a typed element, and let me paste some more code because I want to visit this thing again, but now with typed information. It's almost the same code. Typed element also has a visit statement, and so when I visit it, I'll hit dump element. But you can see that now I'll print the name, the value, which is now an actual value, not a string anymore, And to make sure, I'll do get type so you can see which .NET data type is used and what the FHIR instance type is. So now we have all the type information we need. Well, let's run this test. Build succeeded. Well, that's nice. One passed. Whew. Okay, good. Open additional output. Let me, because these small letters, I have no idea how to manipulate the size. I'll just paste this in here. And as you can see now, we have, well, a lot of this is still a string, even patient ID. You can see it's represented by the .NET type system.string, and it's the FHIR type ID. And birth date is slightly more interesting. That is represented by a type that we've written called date, because it has to handle partial dates that FHIR has. And it's, you know, but the metadata says that it is of the FHIR type date. So now we have typed data, which also means that a deceased, well, it should be there. What have I done wrong? Deceased Boolean. Yeah, now you can see that it actually named deceased. And it's of FHIR type Boolean, and obviously it's represented with the .NET type Boolean as well. Nice. Good. So far, so good. Now, what can we do with I-typed element? As soon as you have data in I-typed element form, you're there. You can run validation on it. You can run FHIR on it. You can run anything you want on it. Let me quickly switch to my presentation again. That's back to screen 1. And so I-typed element really is the central connecting concept. So we've seen that FHIR XML node, and actually I used FHIR JSON node, produces an I-typed element using source node and two-typed element. And we have written internally in HL7 v2.1 that reads v2 and converts it to I-typed element, anything you think of really. And once you're there, you can run the FHIR mapper on it. You can run a validator on it, and you can run FHIR path on it. And also, there's a few internal classes here marked as FHIR XML builder, FHIR JSON builder, FHIR POCO builder. That stuff will take an I-typed element and convert it to XML again, or convert it to JSON. Or the POCO builder, you can almost guess what that does. It takes an I-typed element and builds a POCO from it. So this is actually how we parse. We take we take the XML data or the JSON data, abstract it to an iSource node, add type information, and then use the POCO builder to build a POCO from that. Pretty cool, eh? If you, there's one additional class that I'd like to see that also implements I-typed element, and that thing is called element node. Now, many of my colleagues really have wished that I told them about this class earlier because they've built it all by themselves by hand. So that's why I'm telling you now. There is a class in the API called element node, and element node is like an XML DOM. You can build up by hand an in-memory data structure that does not use POCOs, but it uses element node to field member by member, as you can see here, build up a patient. And it implements I-typed element. Or you can load it from another I-typed element. So you can even read parts of your in-memory DOM tree from another typed element and have a new tree that implements I-typed element. I think that's pretty cool. But then again, it's me who wrote it, so that's not fair. Okay. I'll show you what fun things you can do with share. We're back to my Visual Studio. This works well as well. Yeah. Okay. Let me add a little bit of code because now we have this I-typed element. As I promised you, you can run on the typed element. You can run FHIR path as I'm doing here, or you can convert it to XML. And I also promised you that, and let's do that now immediately, you could take that same type element and turn it into a patient P. And at that moment, of course, we have exactly done what the initial code snippet that I showed you in slide 1 did, which is read JSON and read it, convert it to a patient POCO. So this is what happens internally if you use the parsers, the high-level parsers. But in the meantime, now I also have an XML form, so I've basically converted JSON to XML, and I run this. I don't think we need this anymore. Yeah, let's see. Let's see what this gives. Build succeeded. That's nice. And passed. Yay. Good. Let's take a look at the output. You know what? Copy all. We'll just repeat. We'll go on the same. And here is the output. It's obviously the FHIR path I had there went into the structure and got out the string generated. And here you can see that I converted the JSON to XML, which works all nice and fine. Good. Funnily enough, once you have a patient here, actually the API provides you with extension methods to undo all of this stuff. So you can just do toXML, p.toJSON, p.toTyped element. So there's all kinds of extension methods to go back and forth from iTyped element to POCOs, from POCOs back to typed element. Good. This is all the happy path, right? It would be, because one of the disadvantages of learning the high-level parsers is that when you encounter an error, you encounter an error. It throws an exception and you're done. And this API, once you're to iTyped element, we can actually improve on that. So let me damage this file here a little bit. For example, I'm not so much interested in content, but say I change identifier to identifiers, which is plainly wrong, and deceased Boolean, this is a little bit more subtle, to deceased string. And if I would run this code now, let's just do this visit again, we would, it would throw an error, it would throw an exception, and that is where it will end. Now, the good news is that this iTyped element actually implements what we call streaming error handling. And this means that we can, instead of this just throwing, we can ask it to say, don't throw, but just report the errors to me. And the way we do this, let me just show you, is by putting a using block. Go away with the share. You're still stealing my Visual Studio, right? Yeah. Actually, there we go. So what have I added here? I can comment this out to not spoil our console anymore. So I converted this to a typed element, and now I'm saying, well, using typed element.catch, and there is a lambda here, and this lambda will be executed when something inside this using is throwing an error. So the big advantage of this strategy, obviously, is that not only we don't really get exceptions, which are expensive, but it will also just continue. So I created 2 errors. And now the intention is that once I visited all the nodes and I dumped it, instead of stopping, this will just continue and we'll add all the errors to a list. So in the end here, we'll end up here at a sort of fail, and we can just dump the errors. Maybe because we now know what this looks like, I'll just dump that to debug so it's out of our way. We should only get the errors now if I run this unit test. Let's see. Build succeeded. Yep, 1 failed, yes. And I'm definitely hoping that it is the asserted fail that I have here. Let's take a look. Asserted fail failed, that's promising. Let's take a look at the detailed output. Parsing failed. Type checking, unknown element identifiers, beautiful. choice element C string is suffixed with an unexpected type string. Yay. And as you can see, it didn't stop when it encountered identifiers. We kept on parsing until we also hit the C string, actually until the whole thing get parsed. Of course, I disabled the dump, but you'd see that I dumped the whole tree. So there is a way, and this is a big advantage, I think, over the normal parsing, that you can collect all the errors and then report that to your users. There's one catch that I'd like to show you here. These errors are all semantic errors. If I make a JSON mistake, let me go there. So for example, ID here is not a collection, but I'm turning it into a collection. There we go. Yeah, you'll see that when I run this unit test, it still failed, luckily. Okay, run the unit test. Output. You can see there's not a new error here. There is nothing that complains that the JSON is wrong. And that's because the low-level parsers that parse to I source node are by default in something we call permissive mode. So to get these errors, I will have to get them out of permissive mode. And the way I do that is by obviously changing this line here, which was normally a parse. And this is almost the same line, as you can see, but I gave it settings. And actually, I turned permissive parsing to false. Don't need this line anymore. Let's just run this now. Now we can see element ID does not repeat, so an array must not be used here. Fine. This is really something I'd like for you to really realize, that the default is permissive, and you can make it stricter if you want. Now, I'm going to take a little bit of the QA time, if you allow me, because we had a bad start, of course, because there's one thing I want to show you. You could say that I'm cheating here because I said we were going to be able to parse stuff without using pogos. But as you can see here, then I told you, I use a metadata provider that actually uses pogos. So I am cheating here, and I just want to make sure that you understand that this is just one of the implementations. We can plug this with another implementation. Here, I'll paste the code here. And now I'll put provider 2. Yes, there we are. So what happens here? Here's another implementation of that same interface called structured definition summary provider. And that provides metadata based on external metadata packaged with the NuGet. And the way I've done that is that I have a resolver here. And this resolver basically starts with the zip source, which is packaged with the NuGet, which contains all the structured definitions from the FHIR specification. I put a cached resolver around it to make sure that it doesn't access your disk all the time. And then I pass that as the first argument to structured definition summary provider. And this provider will now do exactly the same job as the POCO structure definition provider did first. So now you have a bit of code here that is completely independent of POCOs. Finally then, because we are almost out of time, let me get back to my slides. No, not from the beginning. No. Yeah, but it's exactly where I wanted to go. I just wanted to show you here, Shift F5 will do the job, we know, that we have written that this whole resolver structure can actually be nested. So you saw me do a zip source, which takes the stuff from a predefined zip file, but there's also a thing called a multi-resolver, which will first try the zip source, and if it doesn't find it, try something else, which is then cached. And then combined with another multi-resolver that takes definitions from your own database. So you can package these definitions in all kinds of ways by implementing this resource resolver interface. And the iResource resolver interface is really simple to implement. And if you implement this one, and I know my Vonk colleagues have done that on top of the database of Vonk, then this whole infrastructure will actually look for the metadata in a place you specify. So either a compiled binary, maybe in your DLL, in a database, wherever you want, by implementing iResource resolver. Great. There is an async version of now. That's one of the new things in the 2.0 API. Not much change except for their async. Just want to point you out to that. And finally, this is my final slide, is that kind of a summary of what we've seen so far. I started out showing you that you can take raw FHIR data, read them into an iSource node, together with an iStructure definition summary provider, turn that into an iTyped element. Now, this iStructure definition summary provider gets its data from iResource resolver I just showed you, or actually, one of the implementations that we started out with, of course, was the POCO structure definition summary provider, which gets the metadata from the POCOs. But the structure definition summary provider gets it from the resource resolvers, and that gets it from the definitions. The top step on top of this, if you want to go on after this, is that you're now in an excellent position to run the full FHIR validator and validate instances against profile. That's really a subject for a whole presentation by itself. There are many presentations about validation this week, but the .NET API has a full-fledged validator that can validate against profiles, and it will take the iTyped element and iResource resolver and validate that data with the full validator. There is a GitHub here, FHIR team FHIR validation demo, and that has exactly code. That's actually a WinForms application that runs almost the code that I showed you today, and also includes the validator. So if you want to know, now I have iTyped element, how do I actually do validation? Take a look at this GitHub repo. And
Ewout, you were just showing not your presentation.
Sorry?
You don't see your PowerPoint slides.
Oh, sorry. Yeah. Thanks. But this means that you didn't see the summary here too. I'm sorry about that. This was the high-level picture where the iSource node and data was. And once you are to iTyped element, you can show the validator. You can actually run the validator. And this GitHub repo, which is the FHIR team validation demo repo, has a code to show how to actually do that. So it contains most of the stuff we saw today, plus code on how to run the validator. That's what I'd like to show. So that means that we still have a little bit of time for questions. If you don't mind, you can unmute now, and I'll be able to answer your questions.
Yeah, and there's also a question in the Q&A. I already see popping up, Ewout. And the question is, what would be the best way to contact you to discuss some big feature before starting work on a PR?
Well, really the best way, of course, is through our GitHub. And in case, let me just show you the main screen again here. Abel, I'm moving you out of the way. I'm sharing.
That's okay.
Yeah. Share you're seeing my Visual Studio right now. Okay. Do you see my Visual Studio?
No, I'm seeing your browser at the moment.
Yeah, that's good. So GitHub, FHIR team .NET API. This is where me and Abel and a few more people are hanging around. And so if you want to discuss, the really best thing to do is to start up an issue here. And so we can discuss it, but also other contributors to the FHIR spec can help us and discuss these features. So that would be another thing to this is probably interesting to mention, is that we are normally not working on the develop branch. if you scroll down, if you go to the FHIR.net SDK and you scroll down, we do mention, I think we do have a contributing here. And we actually work on develop STU3, develop R4, and develop R5 branches, because we are maintaining this library for all these 3 versions. So yeah, this is the way to get started and reach out to us.
Okay, well, thank you. I think people can unmute themselves if they want to ask a question. I said it before, and apparently the Q&A section is also functioning at the moment. So that's great.
Oh, that's nice.
Yeah, but you can unmute yourself if you want to ask a question.
You might want to note the submodules.
Sorry, can you repeat your question?
You might want to note the submodules.
Oh, yes, yes. Yes, thank you for mentioning that. What we are looking now here is the FHIR.net SDK. And if you check that out with Git, you'll see that this actually refers to another Git repo, which is called FHIR.net common. And this repo contains the code that is specific to a FHIR release. So R3, R4, R5. But it has a subrepo called common here. And if you go there, you'll see that we'll switch to FHIR.net common. And this has the code that has no connection to a specific FHIR version. So this contains most of the classes that we've been looking at, the FHIR XML, the FHIR JSON reader, basically the class resource, class identifiers. Most of the, or some of the normative types are in here. Basically everything that has no dependency on a exact version. Now, working with submodules in Git does take, you know, it is a ramp. You have to get used to it, and especially if you, like some do, download repos by downloading the zip. This won't work. So if you download the zip with the FHIR.net SDK, you'll just get a zip with that, and you'll miss out. You'll have an empty common subdirectory. But at least now you know you'll also have to download the common repo. Yeah, thanks for that question.
Okay, anybody else who has a question and who can unmute? Otherwise, if you can't unmute, please send some sort of message on the chat or raise your hand or whatever. It's a little bit of trying out here because I don't know how it works. I don't see anyone raising
Well, that's
their
good
hands.
because then,
yeah.
you know, for those interested, I do have a bit of code that actually takes this I-typed element. I'm still sharing my Visual Studio here, I guess. You see, I've thrown away the other code, and I've added. Here is still our I-typed element coming in from the other provider, and as you can see, I've now added code that creates a validator. I've set the validator to use the same resolver, you know, that external resolver. So also the validator will get its metadata that it needs and its profiles from an external source. We'll run the validator, and the outcome really is an operation outcome. And I'll dump that to the console. So let's go and see if that works. This I haven't tested, so who knows? Let's see what happens. Be brave, we have 2 minutes left. Build succeeded, that's nice. Now I'd like to see a green unit test. Passed, victory, or I think victory. Let's see what the output is. Ah, that's right. Oh, maybe I should undo the mistakes because of obviously the validator. Let's undo, discard the errors. Oh, if you're using submodules, by the way, smart git rules, but that's a short message in between. Okay, let's run this test again. Maybe for multiple reasons, smart git rules. Now I have supposedly valid data again. This is actually the data that's in our unit tests. Build succeeded. Yes, now let's take a look at the output. And you although structurally, before my patient was correct, you can see that once we run the actual patient profile on the data, now all kinds of FHIR path statements are being run, and you can see that our example here, fp test patient.json, still contains quite a lot of errors. So now you've seen that profile validation, which adds another step on top of the syntactic validation that we've done so far, really adds another layer of semantic checks. And only actually if you pass this, you could say that the data is valid. So in your software, you probably have a tiered approach where you can first do the syntactic checks, and if that goes okay, you feed this to a validator, a profile validator, and then you're done.
Yeah, that's great, Ewout. We're out of time. It was a great presentation. Thank you very much.
Well, thanks for staying with me and helping me out with the quick switch to
some glitches. Yeah, but it's okay. It's okay.
It worked out in the end. All right, everyone. Thanks for joining me.
Thank you very much for watching and attending the meeting. And see you all in the rest of DevDays.
Bye.
Bye.